And this should be on page 335 for notes 16.2. Find some empty space on the top of the paper, write coefficient and constant. Let's just discuss these real quick. A coefficient is a number that is attached to a variable. Like 3x, the coefficient would be 3. 3 is attached to x. Or 3/4 x, the coefficient would be 3/4. If a variable is just by itself, such as x, it still has a coefficient. It's kind of invisible. It's right in front. That coefficient is 1. Constant is a number that's all by itself. So in the expression 2x plus 5, the constant is 5, the number that's not attached to a variable. Or 4x minus 8, the constant is negative 8, the number that is not attached to the variable. All right, so let's get started. Arturo and his family are hiring 3 painters, charging $60 per hour each. All right, Arturo's family represents the charge of painting in different ways. Arturo's dad says, hey, we're going to do 60x plus 60x plus 60x. We know that 60x represents the cost of just one painter. And then the entire expression, 60x plus 60x plus 60x, represents the cost of each painter. Now, his mother is going to go ahead and combine those like terms, 60x plus 60x, and say, hey, instead of doing that, we're going to go ahead and just say 180x, and that represents the total cost of the group. So what's in one that isn't in the other? Well, this first one gives you a breakdown of each. Each painter, right? And the second one would give you a total view, a total cost view of the project. Meaning, in the first one, you could say, hey, this is what each painter is going to cost me. In the second one, this is what the total project is going to cost me. Arturo then decides, hey, we're going to do a different expression for the amount of days painting, right? And so, kind of similar here, 480D plus 480D plus 480D represent what each painter costs per day. Whereas if you combine the like terms and you got 1,440D, this would represent the total cost per day. Just two different ways of writing it after combining like terms. Remember, like terms are terms that have the same variable and same exponent. In this case, they have no exponents. Right? Next one, Leah buys 3 adult passes and 3 child passes for a trip. Cost of an adult pass is A. Cost of a child pass is C. She writes it in 3 different ways. First one, she says 3 times A plus C. And this is just 3 different groups of 1 adult and 1 child. Meaning it could be like 3 different trips or 3 different adult-child pairs, right? And the second one is 3A plus 3C, which just represents the cost of all adults together, maybe 3 adults got on the bus together, and all children together, maybe 3 students got on the bus together. Okay? Then all of a sudden Leah says, wait, there's 2 more children that are going to go on. So to modify 3A plus C, well, the 2 more children wouldn't count as an adult-child group. So you would just tack that on as you'd keep the same 3A plus C, and then tack on 2 more children, right? And then the second one, 3A plus 3C, if I tacked on 2 more children here, you could just go ahead and say, oh, that just becomes 3A plus 5C, adding 3C plus 2C to give you 5C. Finally, DeAndre spends the same numbers of hours awake every day. It's pretty consistent. He writes 365A, because there are 365 days in a year, A minus S. So A minus S is the amount of hours awake minus the hours he sleeps. Times 365, that's how many hours he's awake during the year, right? His mother says, wait a second, you can actually go ahead and use this expression instead. Do 365 times the amount you're awake minus 365 minus times 24 minus A. Really, the only difference here is mom says 24 minus A is, okay, that's your sleep, right? And so she's saying if you do 365A minus 365, how much you sleep, you'll get how much you're awake. That makes sense. And DeAndre is simply saying, in his, if I did 365A minus S, it's the same thing, because if I distribute here, I'll get 365A minus 365S. Both will give us the amount of hours that he's awake. Go ahead and do your exit ticket, and then onto your wayground.